Cool. Excellent. So good morning from me as well. As you can see, we're going to talk about MLOps, so there's a number of things I want to talk to you about. And introduction is pretty much done, but yes, I'm Gianluca. I'll tell you maybe a bit more of what I do nowadays. I'm a data scientist at Microsoft in a team called Azure Cat, which has nothing to do with felines. That's customer advisory team, so I fly out to customers. I was in India recently to build AI solutions for them. And part of what we'll see today, what I'm going to talk to you about today, is based on these experiences. And as mentioned, I also run my little company. It's been going on for 4 years now, doing consulting and training in data science. So before we move on, I would like to know who's in the room. And we're going to do this in a slightly different way. So if you go to that website out there, menti.com, and enter that code, I have a couple of questions for you. First one is what you do, and this is entirely up to you. You know, this is your field. You might be studying, you might be working in that field, whatever it is. Hopefully a nice little wall cloud will start appearing very soon. And then I have a second question for you, which will make sense in the context of the talk. Ah, it's working, yes. Yes, data scientist is winning. That's good. That makes sense. I saw biostatistician somewhere. Hello, that used to be me a while ago. So whilst this forms, it's actually great to have a data science audience, and I'm coming to you today more from the computer science, I guess, perspective / software engineering. I know there's a few in there if you look close enough. So I'm going to try and convince you that it is worth to spend a little bit of time automating things and doing it properly. And yeah, so we'll take it from there. Right, so data science and scientist definitely wins. There's a few data analysts, machine learning engineers. Now, second question for you is the amount of coding and data analysis that you do. And of course, the two are somewhat correlated, right? But if I move to the next slide. There we go. You should now have the same website as before. If you've closed it, you can reopen it. But I would like to know what your day-to-day is like, right? And this will move around a lot. By the way, this is not necessarily a good visualization you should be using in your day-to-day, but it kind of works here. So we've got, okay, so that's somewhat higher on the coding than on the data analysis. That's interesting. Right, and there's a nice little spread. That's helpful. So of course, as I was saying, today we're going to be talking a whole lot about not really coding per se, but practices that can help you with that, and of course go into your data analysis and data science. I'm also going to leave this slide up. If you have any questions, but we are too shy, you know, they will accumulate here, so we'll come back to this at a later point. So that, in fact, this should be on present, and I can quit. So this will just be there in the background whilst we chat. So, as I said, we're going to talk about MLOps, which requires definition of ML, though that's probably not needed too much, given the audience, and ops or DevOps in general. But really, we're going to talk about a bunch of mistakes I made recently, and hopefully help you not make the same mistakes. So in terms of ML, the only thing I will mention very briefly and in passing, this slide you might have seen from my talk here at the DSF last year. I like to divide data science into two big fields, and I don't think data science is either one. It's both and a combination. So on the analysis-focused side, you've got things like the traditional maths and statistics, stuff I studied at some point. You've got business intelligence, and really what you want to do is assist human decision-making. This is the analytics side that's been around for a few thousand years now. On the other side, which is perhaps more recent, you've got what I call building-focused data science. And this is traditionally the realm of machine learning and software engineering, developing and deploying data-driven products, which is, of course, slightly different. On this side, I guess, this is more of a post-mortem. You're looking at the past. On the other side, you're building systems that learn automatically and react. So just to give you a flavor of things I've built in the last few years, I built a high-frequency trading system for sports betting. That was before Microsoft, as you might imagine. At Microsoft, I have built a few things so far. One was a kind of personalized search engine that knows where you are and responds. If you look for restaurants, for instance, it will tell you about restaurants around you. And it's personalized so that if you like Italian restaurants, it will show you more of those. What I'm currently working on is this content recommender for a mobile app, and that really gets those feedback loops going. Main challenge for that project particularly is the size and the scale. It's got 25, 26 million users at present, and this is expected to grow. So that really is the challenge there. And the last one that I wanted to mention, going back to that analysis versus building data science, is an automated forecasting tool. This is not really, there's no feedback loops, it's not automated, it just has a little dashboard with outputs, what we think what's going to happen in the future given the time series. And the key there is that it's automated, right? So there's a few things I'm going to talk about which pertain exclusively to the more machine learning solution, the kind of building-focused data science, but there's a lot that can still be applied. If you create a report monthly, you should probably automate it and not have to deal with it anymore. But then if you do so, there's a few problems that's going to be the focus of later today. So that's ML. That's all I'm going to say about ML. Not going to really talk about model building at all. In terms of DevOps, you have this definition, which I stole from Atlassian, which is just automation practices between software developers and the IT team. So it's the people who are running the system and the people who are developing the system, right? And the idea is that if you put some practices, some interfaces in between the two, then you can build, test, and release software. And both will gain peace of mind from this because you can do this more reliably, you can be quicker, you can fix bugs. But really, the definition that I like more is this. So it's a culture, a movement, a philosophy, which really means that I'm going to show you a few things today. It's not necessarily the case that you should go and use all of them. I believe that some of them are useful tools, but again, it depends on what you're trying to do and what your project is about. So I've redefined it. I kind of combined ML and DevOps into one, and I've redefined it as such. So MLOps I'm going to define as any automation practice between data scientists, data engineers. The difference between the two is a bit blurry, but we'll leave it at that. Software developers and IT. And here already you see that there is, especially if you're building systems or ML systems which are integrated as part of a bigger software product, then you will probably be dealing with people who do not necessarily understand what you're doing, right? And they might be, again, the software developers, it might be the people running the servers, or anything like that. I've also added a couple of words to the why. So build, test, and release are still there, but you also have monitoring, which is incredibly important once you start training models automatically. So if you're there and you're looking, you can do your feature engineering and exploration and decide what's a good solution for the data, monitor the performance and whatnot. If you're not there because the model runs itself, that's more complicated. And so that's part of what we're going to be seeing later. And the other part, of course, is software that embeds ML. As I said, ML is typically part of a much larger solution. In the content recommendation, of course, that I was talking about, there's, of course, the mobile app, which is being developed by people who don't necessarily understand what the personalization system is supposed to do. They just call into it and hope for the best. Right. And the reason why we're doing this is that if you really want, again, a slide I partly copied from my presentation last year, if you want that high-risk, high-reward innovation culture where you can quickly iterate, see what sticks, in a sense, this is what MLOps enables you to do. So you can quickly come up with a solution, see if it works, test it out. If it doesn't work, get rid of it, try a new one, and so on and so forth. So this is, if you want, the enabler to this type of culture. And why does it matter and why should you care? Right, of course, if it's not used in production, it never happened. I've had this happen to me a few times before. Beautiful solutions from the stats and ML point of view, absolutely delightful to work with, but then they were never adopted. Right? And this is, of course, a bit disheartening and disappointing, but that's the reality. Now, if it's not used, of course, it never happened, but if it is used in production, it better work. Because, of course, the moment you start building solutions and other systems start depending on your machine learning system to provide, say, recommendations, in my case, if they fail, then your neck is next on the line, which is not a great position to be in. So this is all for that. Now, if you are a data scientist, and we've got quite a few in the room, it is hard, I'm not going to lie. It's not something that you would normally do, right? And you can also perhaps feel that it's unnecessary, but it does pay off. It really does. It gives you peace of mind, as I said, in terms of other people being able to rely on your software. And also, it allows you to focus on more interesting tasks like modeling. Of course, this is not true at first. So you have to put in the effort, which is the first point. And once the infrastructure is there, it then allows you to focus on the interesting tasks. So there is a little bit of a cliff to go over before it becomes really useful and you appreciate the value. Now, if you're instead a software engineer, you probably know what I'm talking about. So there's a few differences with ML-based systems. And again, you want to increase the dependability of those. It also brings you closer to the data science team. And we are a cool crowd, so you should come hang out with us. So that's always good. Now, all of this comes with the caveat that, of course, you shouldn't try to run before you can walk. And I really like this is the pyramid of needs for AI. It's beautiful. And I've stolen it from that lady down there. I've had customers come to us before asking to build ML systems very similar to those I briefly touched upon earlier. They had no data. Right? Of course, if you don't have any data, you can't really do any ML. So my idea is that there is at least some data to work with. So you're maybe here, or maybe a bit further up. So you're thinking about, once you've started getting your data in, properly structured, properly stored somewhere, everything is nice and reliable, then you can think about modeling. That goes without saying. If you don't have data, then don't try and do any of this. Now, in terms of the data science workflow, and there's a few talks, including in this very room later today, about doing this, right? I don't necessarily want to tell you how to do it in practice, but I want to tell you why you should be doing it and why you should be looking into it. Where do you think we are? So this is a kind of, you might have seen different forms of this. This is the one I use. So you start with some research question, obtain some data, start exploring it, get to a model at some point, and then you put it into production or operationalize, as we say in Microsoft. It's a bit of a strange word. Where do you think we are when we talk about MLOps? Who thinks it's the research question? Show me your hands. OK, no one. Is it more in the data exploration? Modeling? Last one? That's what you might think. It was, of course, a trick question. It's a bit of both. I think I'm going to argue, at least, and we'll see if I manage to convince you, that it is, of course, here. This is the bulk of what we're doing. But there's also a lot of things you need to think about in getting data into your system and modeling. And we'll see why. Now, if I change this and I add words that perhaps machine learning engineers or data engineers will be more familiar with. You've got a bunch of data sources, so it might be a single one, it might be multiple, which is a problem in itself. Then you do something called ETL, which we're going to talk about in a second. You develop your model. This is where the magic happens, so we're going to kind of skip this because you're all data scientists, so you know about that. Then you train your model, and finally you deploy it somewhere where it's ready to be used. So we're going to talk about these three. Right. So ETL is officially extract, transform, load. It's been around since the 70s or so very long time. I refer to it as data science alchemy because you turn lead into gold. You transform horrible-looking data into something that you can feed into a machine learning algorithm. And of course, this is typically heavily informed by your initial EDA, right? You look at the data, and then you start understanding what's valuable, what kind of seems to predict or at least be correlated with your target, whatever it might be. And then you start building that first step of ingesting lead and turning it into gold for your model, which is exactly what that extract, transform, load means, the transform being the magic. So there's a few things that you might not be thinking about immediately, but are quite important. The first one is that you should try and kind of put yourself in that mindset of this is going to happen multiple times on a schedule, perhaps automatically. And when you look at things, you might think, okay, this is my variable and it has numbers. Perhaps it's, say, revenue and it's expressed in thousands of pounds. And then you kind of know what normal values should be for your business, and you have a rough idea of the distribution. Now imagine that someone decides at some point to change that from thousands of pounds to millions of pounds for whatever reason. Then, of course, everything further down will break miserably. And I've had this happen to me. Someone, for whatever reason, decided that they should change the scale of a variable, which, of course, threw off the model entirely. There's also transformations. Very often, we take data and we transform it somehow before we can use it in a model. Now, if you're doing, say, a log transform, then that's fine. The log is well-defined. We kind of all know what it is. In other instances, you might end up building other models. For instance, if you're doing NLP, you might train, and NLP is not what you're trying to do, right? You're trying to do an entirely different model. NLP by me might be a transformation step. Maybe you train an embedding on your training data. You get out some numbers. This is the example I recently worked on. And you get out your new features. So in that case, that transformation needs to be available later on, right? You're not doing, again, remember, we're not doing this once, we're doing this multiple times, which means that you need to be able to replicate any transformation on the data when you're using your model. And then, of course, you have external data sources. This is, again, a pain because, and again, I have an example for you here. For forecasting, since the business I was working with deals in multiple currencies, you might want, and you might think to yourself, okay, why not report everything in GBP, for instance, so that we can aggregate things and it actually makes sense. Now, suddenly, you have a dependency on knowing what the currency, the FX rates are for GBP, say, to euro or to US dollars and blah, blah, blah. And this is not part of your data set, but now you need to somehow acquire that information, which is publicly available, but perhaps you need to write a scraper for it or something of the like. So you need to get that additional data feed in. And that's a pain, or a pain that data scientists don't normally want to deal with. Now, I lied. We're actually going to talk slightly about model development. The reason for this is that there's a couple of things which I think are quite cool and I want to kind of put on your radar. One is how you do hyperparameter tuning, and the other one is automated ML, AutoML. So many cloud services, which I'm going to point to you out later in the course of the presentation, provide some sort of both of these services. So when I talk about hyperparameter tuning, I guess you know what that is, but the facilities which are now available can allow you to run your model just by getting some parameters in. Everything is nicely parallelized. Some of them provide Bayesian exploration, or rather than more common grid search. So all of this can be done, and it is in a sense abstracted away. You don't really need to think about it. AutoML is this plus a step further because you also start searching across the space of models. So in a sense, that's supposed to be putting us all out of our work, but of course you know that the data transformation is where the magic happens. Main thing to keep in mind here is the choice of programming language. I'm not going to enter that debate. Of course, you should be using Python because that's the most well-supported. But you can be using R. I've used R for many years and still like it very much. Or you could be using Julia. Or perhaps you should be programming stuff in Go or in Rust or in C or in C++ or in Java. So there's a lot here. This will come later on. Python is an excellent first solution. I've had a lot of pain with it and a lot of love. So you can come and talk to me during the coffee break about that. Other things to think about, versioning. I am going to be very unpopular after this, but I do not like Jupyter notebooks. And the reason for that is that versioning is a bit of a pain, and running them on a schedule is also a bit of a pain. And I know there are solutions like Papermill and all that, and then MB compare. But still, version control is important. The Git time machine is beautiful, and you should be using it. And the last one is performance tracking, because very often when you're developing a model, you start trying different things out, right? And perhaps you add a variable, or you remove a variable, and add an interaction term, and change the number of trees in the XGBoost model and whatnot. And you get lost, because now you have metrics everywhere. And of course, you could be using an Excel spreadsheet, but it's 2019, so maybe let's not do that. And maybe let's have a nice dashboard. This is what Microsoft came up with, but you have similar solutions on AWS and Google Cloud. I'm just showing you this because, of course, these are the people who pay my salary, but also because I have access to it. So you can get nice little dashboards. That's your MSE, say this is your alpha, your regularization parameter, very quickly. And they all have similar concepts where you can create experiments, you can have multiple runs. It runs in parallel, so you don't really need, say you're doing hyperparameter tuning, you don't really need to think too much about the execution, just write your code and submit it. So this eases some of the pain. Of course, the pain is shifted to having to learn the library, the Python SDK for this, but then, in a sense, it removes pain further down the line. Now, on this, since we're talking about metrics and MSE, this is something I was discussing with a customer a couple of days ago. Anytime you start exposing a machine learning model out to the public, you have two metrics, right? When you put it out, you have missed metrics. For instance, they'll come to you and say, well, we want users to be more engaged with the content, which means they click on it more. Typically, that's what it is. So these you can measure, of course, because you put the system out, and then you measure how many users click on, say, your search result, your personalized search results versus not. Now, when you're training the model, perhaps you're looking at log loss or AUC, so online metrics, which is a bit of a problem. And you want to experiment early and often to be able to understand what the link between the two is. And similarly, if you start introducing feedback loops, then you have this self-fulfilling prophecies, and the model starts biasing the data that's collected. So you have to somehow introduce some exploration, some randomness into the model to collect good data. Now, training the model, I guess, is quite obvious. You start with historical data. You create a model. Maybe you do this on a schedule, kind of as an offline job. Scoring the model is slightly different because now you have model, which came from there. You've got new data, and you have to generate predictions. And you can do this online, as in the user comes to the website, and you have to produce predictions in a few tens of milliseconds, or you can do this offline in a batch mode. So this then informs your choice of deployment. As I said, you might do it entirely offline. This is kind of what you do on your laptop, I guess. You can use queues. You can generate APIs, REST endpoints, for instance, as remote procedure calls. Or you can also integrate your machine learning model inside the software that's running, say, the rest of the website. This, of course, gives you the best performance, but it's the hardest to do. And when I say performance, I'm mostly thinking about throughput, so how quick it is, latency, and what requirements you have. Of course, if you have 600 requests a second, which was one of my requirements in the last project I worked on. That's very different from having very little traffic or kind of having more time for this. There's also, and we go back to Python, some sort of impedance mismatch between how you train your model and this scoring part and deployment. And I'm looking at you, Apache Spark, because that's been a lot of pain. Spark is beautiful for training on very large data sets, but then, of course, once you need to do this in a much faster and kind of low latency environment, it becomes painful. And there's also a lot of other considerations which I don't want to go into. There's security, there's access control, there's other moving parts, and databases involved. Online deployment, again, not going to talk about it too much because it will come in talks later today, but it seems that quite a few people converged, and I'll show you a link to what some of my colleagues came up with a combination of Docker and Kubernetes for kind of deploying models out as REST APIs. Things to keep in mind here are how you're going to split your traffic, how you're going to do your A/B testing, because of course you don't want to expose, you can expose 100% of your users to your model, but it's probably not a good idea. It's probably better if you test it out first and then incrementally roll it out to all of them. So we've seen a lot, and you might think, well, we're done, right? But not really. It needs to be automated, which means that once you're retraining, you need to keep everything in mind again, because this is now running on a schedule, which means you're not there to look after it. If your data starts becoming different from the training data, if your performance starts degrading, that's something that you need to catch, and you need to catch automatically. So, of course, the solution to all of this, which is a tried and tested software engineering solution, is to log everything you can. Any assumptions, verify them. If the data is, again, drifting, the performance of the model in terms of AUC or any metric that you're interested in, but also how long it takes for it to respond, if you're interested in that. And decide what happens when the model fails, right? Because this can happen, and how should the rest of the system respond? Again, you have nice solutions. You don't need to do a lot. This is App Insights, again, from Microsoft. Similar solutions, again, exist for AWS and GCP. So you get a nice little dashboard. You also get anomaly detection on the time series if there's any spikes or anything that you see occurring. I've had this, again, recently with a customer who decided that they would start sending 3 times the amount of data they were sending previously. Without alerting us, of course, which caused a lot of nice spikes in here. But of course, if you don't have this, you don't know that there is a problem. And now we're really done. Now that's really the end. But then you need to do it all again. And of course, you'll want a new model, right? Okay. So you have, well, it's going to be difficult. So you now have versioning. You have to think about how you can go back with, if you want to return to a previous version of the model because the new one doesn't really work, you need to think about that as well. You need to think about how you experiment. First, you had, one version of the model, and you were comparing that perhaps to no model at all. But suddenly you start having 2, 3, 4, 5, 10 different models competing and running there. So all of this needs to be taken into account somehow. And yeah, again, a few solutions. So this is what the final picture looks like a bit more. You've got model development, you've got retraining, you've got the ETL down there, and deployment itself is not that simple, right? There's a lot around it. There's experimentation, trying different models, and there's a whole bunch of monitoring required. So my final recommendations, if you want, as a data scientist, it does pay off, as I said, familiarize yourself with the tools. Most of them are Python SDKs, so you can quite quickly ramp up with them. And then try moving some of your workloads away from your laptop, right? Try not just having all your models in notebooks, but try kind of getting into this mindset. And if engineering comes to you and says, well, we want more reliability, we want more assurances regarding the ML system, understand where they're coming from. They're not just pestering you, there's a reason behind it. And as a software engineer, of course, if you've not done already the containers and the whole orchestration with Kubernetes has been around for a while now, but it pays off again to check that out. And also the different cloud offerings, which I'm going to show you in a second. And again, help your fellow data scientists, because we need that. That's me. So thank you very much. If you want to keep in touch, I'm on GitHub and LinkedIn, so just add me/follow me. Thank you.
Thank you. We have around 10 minutes for questions, so perhaps I'll collect a few in a batch. Yeah.
Yes, thank you. Yeah, it doesn't. Thank you. Cool.
Right. Thank you for the presentation. I have a question. Do you have maybe any resources to recommend for MLOps, like guidelines, something similar to PEP8 if you want, that maybe we can start working from there, essentially?
Yep. So this.
Oh, shall I take a few in a batch? And then
if you
we
want.
Can...
Yep.
Can I get another question? Yep.
A slightly different question. You talked a little bit about detecting data drift, but a lot of times with these models, the input data is extremely high dimensional, like images or time series. So do you have favorite methods for detecting drift in that sort of very high dimensional domain?
And then do we have one more? No?
Next, yeah.
Oh!
Hi. So in DevOps, there's been a move to put DevSecOps, put security very firmly at the heart of the code. Are you seeing a similar thing in MLOps?
Thank you.
Okay. So resources first. If you go to my GitHub account, you're going to find the slides for today, and I've got a few things linked in here. The very last link, as I mentioned, is something that some colleagues of mine have produced, and the tutorial in particular kind of covers a lot of these aspects and how to put everything together. So I think this is an excellent resource to go through. In terms of data drift for high dimensional, that's an excellent question. I've not really seen any good solutions. Of course, if you have kind of smallish data sets, you can just look at the distribution. If it's categorical continuous, you have, of course, different metrics, but that kind of works. If you have images, which I think is what you were thinking of, I've not really seen much, to be honest. I know Microsoft is putting out some sort of Python SDK again for data drift detection, but I do not think they've addressed that issue yet. So that's an issue. For security, yes, it's there. To be honest, I've not really seen it too much in terms of course, you can create a REST API and you can somehow have keys to be able to access it or harden the system. I don't think there's much more beyond that in terms also of, say, detecting if someone is calling it too much, but this is everything or all things that can be kind of linked up with the more traditional REST API development pipeline. So answer is not so much, to be honest.
Okay. Do we have another batch of questions? We have one here.
I've got some here.
Yep. Who was over here?
Is it the same? Excellent.
Do we want to take a few more? Anyone from the back? Question?
Got another one.
No.
Ooh, okay.
Any other questions from the floor?
I've got two here, so I can go through them.
Yep, okay. Wow. So
what solutions do you use in place of Jupyter notebooks? Pure Python files, to be honest, most of the time, with some IDE. VS Code is probably one of the very few good Microsoft products. And it's actually pretty nice. It's nothing to do with Visual Studio in case that's putting you off, which it should. So normally just that. I understand, by the way, this doesn't mean that I don't use Jupyter Notebooks. I use Jupyter Notebooks a lot. And they're fantastic for certain things, like kind of if you're trying to explore things. I do prefer, I have to say, how Databricks have done it, in the sense that a Databricks notebooks, which is kind of a Spark-enabled notebook, is just a Python file with some magic comments that create the cells and whatnot. I don't really like the whole JSON file where you store images in line and all that Jupyter Notebooks do. So that most of the time. And in terms of popular services on Azure for MLOps, Microsoft recently launched the third incarnation of machine learning services. If you've used ML Studio, again, you'll be pleased to know that's not a thing anymore. So this is what it is. And Google have recently launched the AI platform, which is pretty much the same, and Amazon has had SageMaker for a while. So you have a number of options in here, and if you want to create Docker images, for instance, directly from a scikit-learn model, there's a quick and easy way of doing so without having to do it manually. But in terms of what you have, so you have model management, which is that dashboard I showed you earlier. They do interpretability as well, and the most useful, I think, is pipelines. I know there's a few talks later today on this, but you can automate all of this. If you've used similar systems, kind of like Airflow is a commonly used one, you can create all your different steps, say, and then have them run one after the other. So it kind of takes into account the dependency. You can't run the model if you've not gone through the ETL, the data preparation. So it takes into account all of that, and you can set it to run on a schedule. You can just ping it, and it will start running. So I've seen this work really well. There's some customers running some 30,000 pipelines a day, and it just scales up and works beautifully. Cool.
Oh, do we have
more.
any more? Oh, great.
Why should you use MLOps solution by a cloud provider rather than cloud-agnostic tools such as MLflow? It's an excellent question. You should use, I think, whatever works for you. MLflow is integrated with the rest, and Databricks, which are behind it, might also have a hidden agenda, like Microsoft, for you to kind of lock you into a cloud provider. But really, you could be building a lot of this stuff yourself, and I've built the whole model deployment pipeline using Docker and Kubernetes manually before, and it eventually became the product that is out there just now. So it's just a matter of convenience. And as I said, you can move things around. It's not too difficult, or I think it's less difficult than with other solutions. But it's just convenience, to be honest. Can Python really be used in production? Oh, dear. Ooh. I don't know what to say. Yeah, perhaps, with a lot of caching and proxies in front of it. It can. I mean, we did high-frequency trading in Python before, and you can keep it to under 10 milliseconds. It's not Python anymore at that point. It's C++ with a very thin veneer of Python on top. But it can be done. And if you think of it more as a glue language, I guess it makes more sense. But if you want to come and chat during coffee, we can chat about this. Cool. I think that was all the questions.
Okay. Can we thank Gianluca in the traditional way?
Thank you.
Thank you.